Welcome back. The topic of this interactive video lesson is on advanced Venn diagrams and probability. 3-event probability. When a probability situation involves 3 events, we can use a Venn diagram with 3 circles to sort the outcomes. All outcomes associated with event A will be in this circle. All outcomes associated with event B will be in this circle. And all outcomes associated with event C will be in this circle. All outcomes associated with 2 or more events will be in the overlapping areas. All possible outcomes of the probability experiment are contained in the box. All outcomes not associated with events A, B, or C are in the box but outside the circles. Set theory symbols. Let's pretend we have a number wheel with the numbers 1 through 20. We'll define event A as spinning a number that is a multiple of 3. We'll define event B as spinning a number that is a multiple of 4. And we'll define event C as spinning a number that is a multiple of event 5. Notice I've labeled these. Now we'll add the outcomes into their proper places in the Venn diagram. Set A is shown as 3, 6, 9, 12, 15, and 18. Set B is shown as 4, 8, 12, 16, and 20. The set of A, but not B, is written like this: A\B. And that's the set 3, 6, 9, 15, and 18. The set of B, but not A, written like this, is 4, 8, 16, and 20. The set of any outcome except A is written like this. I'll call this either A prime, A complement, or the complement of A. It's all of these. Those are the numbers 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19, and 20. The union of A and B is written like this: A union B. Those numbers are 3, 4, 6, 8, 9, 12, 15, 16, 18, and 20. The intersection of A and B is shown like this. I'll call this A intersect B. The only one here is 12. The intersection of A, B, and C is shown as A intersect B intersect C. Note there's nothing in there, so this is the empty set, and we can write it with this symbol shown on the screen. Let's review. When I give you a description, use set theory symbols to represent it. You may want to pause the lesson, write down what you think, then resume the lesson to check. Let's get started. Set A. Well, that would look like this. Set B. That would look like this. Set A, but not set B. We will write that like so. Set B, but not set A. That's written like this. Set A or set B. Well, or is a union, so it would be written like so. Set A and set B. Well, and is an intersection, so it would be written like this. Not set A. Well, that's this. That's A prime, A complement, or the complement of A. Now we'll use this Venn diagram to solve some probability questions. What is the probability of spinning a multiple of 3? Well, the multiples of 3 are all contained in set A. There are 6 outcomes out of 20 possibilities. So the probability of event A is 6/20ths, or 3/10ths, or 30%. What is the probability of spinning a multiple of 4? Well, that's set B, these numbers here. There are 5 outcomes out of 20. So the probability of B is 5/20ths, or 25/100ths, or 25%. What is the probability of spinning a multiple of 5? Well, that's set C. There are 4 outcomes out of 20, so the probability of C is 4/20ths, or 2/10ths, or 20%. What is the probability of A union B? Hint, that's A or B. It's all of these numbers right here. So there are 10 outcomes out of 20. So the probability of A union B is 10/20ths. That's 5/10ths, or 50%. What is the probability of A intersect B? Hint, that's A and B. Well, that's just this number right here. That's 1 outcome out of 20. So the probability of A intersect B is 1/20th, which is 5/100ths, or 5%. What is the probability of A and not B? Well, that's these numbers right here. That's 5 outcomes out of 20. So the probability of A not B is 5/20ths, or 25/100ths, or 25%. What is the probability of A prime? Remember, that's also A complement, or not A. Well, that would be all of these numbers right here. That's 14 outcomes out of 20. So the probability of A prime is 14/20ths. That's 7/10ths, or 70%. This diagram shows every outcome of the experiment, but we often tally up the outcomes in every section like this. Looking at just the numbers that are in A and nothing else, we put those here. There's 4 of them. Likewise, the numbers that are just in B and nothing else will go here. The amount of numbers that are just in C and nothing else will go here. The intersection between A and C will go here. The amount of the intersection between A and B will go here. The tally for the intersection between B and C will go here. For the intersection between A, B, and C will go right here. Since there's nothing, we'll put a 0. And then for everything else, we'll list that number right here. This Venn diagram says 6 of the numbers in the set from 1 to 20 are multiples of 3. 5 of the numbers in the set from 1 to 20 are multiples of 4. 4 of the numbers in the set from 1 to 20 are multiples of 5. Solving problems with 3-circle Venn diagrams is like playing a word or number game where we can use algebra to find the missing numbers. First, we'll indicate the totals for sections A, B, and C. Next, we'll indicate the total for the intersections of each set. Now, we'll show the intersection of all 3 sections. This value is unknown, so we substitute the variable x. Now we'll have to rename the other half of each football shape. This is 5 minus x, here's 3 minus x, and here's 4 minus x. The universal set is the sum of all numbers in the box. We'll label that with this U. And finally, we'll show the union of A, B, and C. Since the universal set and the union of all three is the same, the difference is 0. So there's nothing outside of this. Now we'll represent the value of this section, right here. We know it is 15 minus the white sections. That would be 4 minus x plus 5 minus x. Combine the like terms in the brackets. Now distribute the subtraction sign over the brackets. Now combine like terms. And we have 6 plus x right here. Now repeat the same steps for these sections. Looking here, we have 10 minus the overlapping sections. That would be 3 minus x plus 5 minus x. Combining like terms inside the brackets, distributing the minus sign. Combining like terms again, we get 2 plus x for this section here. Now looking in here at this circle, we start with 20 minus the overlap. That would be 4 minus x plus 3 minus x. Combining like terms inside the brackets, distributing the minus sign over the brackets. Combining like terms again, we get 13 plus x. Now we have enough information to solve for x. The values in the sections add up to 35. So 6 plus x, plus 5 minus x, plus 2 plus x, plus 4 minus x, plus 3 minus x, plus 13 plus x, all have to add up to 35. Summing all these up, we get 33 plus x. We know that equals 35. Now we can subtract 33 from both sides, and we see that x is 2. Now we can substitute 2 for x in all of the expressions. With a little algebra, we found all of the missing values. All right, now you're ready for more examples and practice.